There are some problems in integration by parts that you'd think would be fairly simple, such as the integral of e to the x times cosine of x. But what you find is that when you do these problems, you often end up repeating integration by parts method and you never seem to get anywhere. However, there is a trick to solve this kind of problem.
Okay, so we're going to begin doing integration by parts the standard way. So I'm going to find my u value, my dv value, my du value, and my v. Okay, so our u is going to be e to the x. We take the derivative of e to the x, get e to the x dx for du. Our dv value will be cosine x dx. If we take the integral of that, we're going to end up with sine x as our v value. So now I'm going to use the integration by parts formula. So u times v is going to get us e to the x sine x minus the integral of v du, which would give us sine x e to the x dx. And now, once again, we have a integral that can only be solved using integration by parts. So I'm going to repeat integration by parts. We're going to end up, u is going to be e to the x, so our du, the derivative of e to the x, will be e to the x dx. Our dv will be sine x dx, and our v will be the integral of sine x, which is negative cosine x. So once again, I'm going to apply my integration by parts. So u times v is going to leave us with negative cosine x e to the x minus the integral of negative, or v du, negative cosine x e to the x dx. And now I'm going to simplify all my signs. So I'm going to e to the x sine x. I'm going to leave that for a minute. Pull out the negative right there, so we get a positive, or a plus cosine x e to the x dx. And then I'm going to distribute my negative in here and get e to the x sine x plus cosine x e to the x minus the integral of cosine x e to the x dx. Now if you look at these two integrals, they're the same. I could keep doing integration by parts and just go in an endless circle. But what I'm going to do to end this circle is I'm going to set this whole equation equal to our original integral. So I'm going to get the integral of e to the x cosine x dx.
Which is of course true because all we've been doing up to this point is solving that integral, so they do equal.
And that's equal to this whole line. Cosine x, and then just imagine a dx there. Don't have enough room on this piece of paper. And what I'm going to do is, since these are like the same exact term, they're each e to the x cosine x dx, I'm going to add this over and end up with 2 times the integral of e to the x cosine x dx equals e to the x sine x plus cosine x e to the x. And now to finish, I'm going to divide everything by 2 to figure out what the original integral equals. So 2, that cancels that out. So we're going to end up with the integral e to the x cosine x dx equals e to the x sine x plus cosine x e to the x all over 2 plus c. And that is how you do an integration by parts problem that keeps repeating itself.